I don't even know what it is. I just want to know.
Well, I mean, isn't that our world today, though?
Yeah.
I mean, we've gotten so desensitized to the daily rando news cycle stuff that it's like we're not even phased anymore.
Yeah.
You know, thousands of people are murdered overnight. Yeah. What's the stock market looking like today? What's the price of gas? You know, we invaded Venezuela. Yeah, I've never been there. It's really the problem with invading Venezuela to me is cruise ships going through Panama Canal are a little bit more sketch. You know, you're not stopping at all the stops you used to stop at. Colombia, that's kind of off limits now. Last time I was in Colombia, it was awesome. For like the fifth time straight, my wife forgot her shoehorn thing that she has like one of the long ones. She can't bend over with her treatment and stuff. So but she keeps forgetting to bring it. So then I have to get, and she won't get off the ships at these places. So then I get off these ships in these like third world countries on a mission to find a shoehorn from one of these people who are making trinkets on the side of the road. And so last time, one time in Colombia, all great stories start this way. I found this place there where they had uh, it was a salad set, like a big long spoon, a big long fork for like doing salad stuff. I didn't want the fork. I wanted the spoon. Apparently, they were sold as a set. I'm not interested. let's I got that spoon for $2. Well, no, the best part is this. 15 minutes later, I found a very similar spoon that also had a back scratcher in the other end. I returned the $2 spoon. Got that other one for $3. I mean, this thing was made out of like carved, like hardwood. We still have it today. Oh yeah. I mean, this thing's solid. Yeah, you could like let a bear scratch your back with the thing and you'd be fine. Well, you might not be fine, but the thing would be fine. The back scratcher would totally make it. All right. What's this?
What are you doing?
Yeah, where's Brady?
I saw him. I saw him pass me by.
Yeah, see, this doesn't bode well. These are both people who are also trying to access my money for um, expensive AI stuff and things like that. And I can't even show up to my class. I put pants on for this. Who? Oh. I heard you pulled an all-nighter.
No, I'm here now, including start now.
He's like on so much caffeine. It's this guy's developed like a significant twitch and he's trying to stop it. You missed the story that started with one time in Colombia. No. You have to watch the recording. I have the recording on.
And cost $3. Hard wood. What? Hard wood?
Okay. What's in my head? I can't say. The recording started. All right, let's start. We want to get back towards code here. All right, so we were am I recording? Sorry, I think I am. So we got the Colombia story. The segue was since we took over Venezuela, I can no longer visit Colombia on cruise ships because they don't let you stop there because I guess they're the next target. But there was a story within Colombia the last time I was there on foot. All right, so MVC, we talked about model view, or we talked about design patterns, propose good solution to a common problem. What's a common problem? What's a good solution? Yada, yada, yada. Several of these kind of float to the top. We talked about singleton. That's one of them. Another one that we're not really going to talk about, but you'll see somewhere. And so many of these have kind of just become integrated into products where you don't even necessarily hear about the design pattern aspect of it anymore because you have products bolted around them at this point. But like another famous one is called the factory design pattern, which effectively says you have something in the sky that produces things for you that you need. Whenever you need something, please give me what I need. It gives it to you. That's a factory. It's not a, it's effectively a singleton with some functions in it, is what it comes down to. All right, so MVC, another, probably actually our most famous one that's not necessarily talked about that much, but model view controller says separate your data. So model is your data, your view, your user interface, what people see, and your controller, the code behind that makes the logic, the things that make it work. Keep those in three separate places. Why? Because in the early days of really the internet, this probably came about, or this really started being a problem with a language called PHP. And how many of you have ever written anything in PHP? Just an embarrassment. PHP is still pretty popular today. So PHP was a loosely typed language, very much like Python Carnival. I mean, we'll just talk to the empty chair. It's fine. Loosely typed language. It was interpreted. It was almost solely interpreted by the PHP module for the Apache web server initially. So this language was built for web development. It's still a standard loosely typed language. You can do whatever you want with it, if you really wanted to, but nobody did. People were not writing their own, local programs in PHP, even though they could. They really wanted to. They were using it to write the back end, the controller aspect of, let's call it early days controller aspect of websites. And so what would happen is with PHP, let me hide this guy. So PHP is similar to other technology like, how many have heard of JSP? Java server pages is what JSP is. That's Java syntax embedded within a web page, just like PHP works. So similar to other technologies like JSP, ASP.NET. How many of you heard of that? They would be ASPX. ASPX. You will listen to me. Is that like what is up with that? All right. So if you do, how many of you ever gone into Visual Studio and said, I want to make a web page? And you start doing the drag and drop web page crap? You guys are killing me.
Like the HTML and CSS kind of web page.
Well, I mean, yeah, I mean, there are many, many, many sites out there that are web pages built with .NET. They use ASP.NET. And ASP.NET is Microsoft server pages that allow you to have any one of their languages as the back end. Most people pick C#. So now you could write your web pages with C# embedded in them. And this is stuff that came out a decade ago or longer. This is not new stuff. God, you're killing me. All right, so anyways, you had these collections of software, but PHP was the first one, the first real one, let's say. You had some stuff before PHP. There was a product called Cold Fusion. If you do IT work, you might run into one of these small companies that spent a whole bunch of money 20 years ago on something and they don't want to replace it. So you might run into something still running on Cold Fusion, which is a very proprietary thing. Another technology that, well, actually, it post-dated this. So I was going to say Ruby on Rails, but it post-dated this guy. But in any case, so PHP, very popular, written specifically for doing web stuff, even though you didn't, it had web very much in mind when it was developed. So embedded within it is a whole bunch of stuff you typically do with web pages. For example, talking to backend databases. So for instance, prior to that, you would have had to set up your database. You would have had to set up like an OBDC connection on Windows if you were using it on that. You know, it was not convenient to have your stuff talk to a database, especially if it was web-based. So what PHP did is it added functionality to be able to handle that conveniently. It's 3 lines of code and you're connected to a MySQL database or insert your favorite SQL-based database. So what ended up happening is, keep in mind that this is in kind of the early days of the internet. What we view as our standard web pages today, even boring web pages, are so far beyond what the pages looked like in the early days of the internet. So what we had is we had pages with just mostly text, a couple little images on it or something like that. They were like billboards. Then they started getting a little bit multifunction where they let you authenticate or stuff like that, or have a little bit of dynamic crap happening in the background, that kind of stuff. But as the demands got higher, computers kept getting faster, which meant our servers got faster. The internet speeds kept getting faster. So moving amounts of data across the internet was not as big of an issue. We look at sites today. You go to a website today that has a lot of stuff going on. I mean, that might have been 60 megabytes of website that you just downloaded. Not that big a deal with today's internet. 60 megabytes of data over dial-up, that is substantial time for a page to load. I mean, so dial-up was 56 kilobits per second. So 56 kilobits per second, you have to divide that by 8. That gets you 7 kilobytes per second. Okay, we know about kilobytes, right? Okay, which gives you, divided by 1,024, that many megabytes per second. So now you need to do all of that. And what number did I use for the number of megabytes for a site? Huh? I said 60? Ooh, my gosh, that's going to suck. Okay, so that's the number of seconds. Divided by that is the number of minutes. Divided by that is the number of hours. So 2.4 hours to load a standard, fancier website today. How many of you would be willing to wait for that? You got the little spinner? You assume the software's locked up after about, what, 2 minutes? It's not doing what it's supposed to be doing. You're not sitting there waiting for 2.5 hours for that. If you had a progress bar and you saw it moving at a snail's pace, you might not even be able to notice the movement. You might have to do one of those little, like, see where it lines up to with something else on your screen, and then come back 10 minutes later and see if it's moved, if it's on the other side of the same letter.
Pretty much take about that time if you're not using it.
Oh my gosh, you just walked into something horrific.
I did.
We're never going to get back to code, people.
Oh,
Just ignore it. Ignore your.
No, this is super important. What is Ethernet? Now, I want to point something out here. I had the same discussion with one of our top seniors yesterday, and he had no idea either. Yeah, this is ridiculous. This is what we're graduating these days. This is what's coming out of computer science. What's Ethernet?
Just wires and stuff.
Just wires and stuff. No. Ethernet has nothing to do with wires. Wires are the mediums that our data travels along. They're like internet, or interstates, right? They're roads. They're the roads that our data drives along. What's Ethernet? Ethernet is a network protocol that our modern computer networks have used for years and years. Don't confuse network with internet. We had computer networks for years and years and years before the internet. How many of you have heard of a LAN party? What's a LAN party? Well, this is way before Call of Duty. So the last LAN party that I recall we had here, there was a game. I think the game's still out, but this is like version 0.8 beta. It was a game called Counter-Strike. Okay, kind of one of, I guess it's one of the OG shooters. Okay, so a game called Counter-Strike. This is not an internet-aware game. All right, so this game was more meant for groups of people who were on the same network could play against each other, okay? Or you could play solo. So what the students would do is they'd all bring their desktop computers. We didn't have very powerful laptops back then, but some people might be had a really high-end laptop because Counter-Strike is, back then didn't require super high. We weren't at the point where we were pushing the $4,000 GPUs. We were at the point where if you had a really good gaming laptop, maybe. So they would all, get around in a classroom, set their computers up, all connect through a wire, okay, to a switch. So they were all on the same local area network. And they would connect and start, and play. And they could all see each other so they could create 5v5s and stuff like that because they were all on the same local network. Internet didn't exist. So a network is a way for computers to communicate with each other. Now, in the old days, we had all sorts of older protocols like ARPANET. Token Ring was a popular one for years and years. Well, then we landed on Ethernet. Ethernet, see, Token Ring, if you're looking at performance for networks, Token Ring had the problem where you were only allowed to send data if you had the token. Kind of, if your computer held the baton, it was your turn to do stuff. If you had nothing to do, you handed the baton off. If you had something to do, you could only hold the baton for so long, so you had to do as much of it as you could, and then you hand the baton off. The network did all this for you. That was all the timing and stuff. Well, that doesn't seem like that's going to really cut it if you have a bunch of people competing over that, right? So Ethernet comes out. Ethernet's like a lazy river. Okay, so you have all these computers hooked up, and think of it as like there's just a lazy river of data flowing around the network. And your network interface card would just kind of dip a ladle in it, or the Colombian back scratcher would just dip that spoon side into it and bring up data and then sift through it and say, is any of this for me? Right? Because Ethernet, the little tubes that are floating around that lazy river are called packets. Ethernet's a packet switch network. So you had packets, little containers of data that are floating along there. So you'd scoop up the packets and sift through and say, this one's for me. Do that stuff, and you work with it. So you had access to everybody else's packets. Okay. Hey, welcome encryption. So we're going to start encrypting that stuff to make sure you can't just read anybody's packets. But you know how to read your own packets because you have the key, that kind of stuff. So that's what Ethernet actually is. It's the mechanism, it's the protocol by which data travels on a network. You can have that traveling over wires. You can have that traveling over wireless. All our wired network and all our wireless network are all speaking Ethernet. These are Ethernet networks. The cable doesn't matter. Because they're ignorant of the details behind it. Yeah. Right. Now well, frankly, you'll probably forget this whole conversation. That's been my experience.
Yeah, I'll forget it.
So, well, then we have a problem. If you got this lazy river of packets floating around and you got people rooting around in there with sticks, what are some things that might happen?
Slow it down.
or data gets broken up, or bad things. You got somebody with somebody in the lazy river is sitting there with one. I don't know, what do you like? They get like an outboard motor down in there, and they're just kind of just throwing up stuff. Things are going right. You're losing stuff in that. And then, how many of you have ever been in a lazy river before? Sometimes you get those collisions, right? The tubes, man, the last person you want to run into is me. You also do not want to go down the water slide before me. When you hit the end, you need to clear. Because I'm coming down that water slide with a vengeance. Gravity's a thing, people. And once I get locked in where everything gets suctioned to the bottom of the slide, then there's no more friction. I'm going Mach 3 down that thing. I had a former student one time that went before me. We were up at Blue Harbor, not even a big water park. We were up at Blue Harbor up in Sheboygan, indoor water park. And he landed and he stood there way too long. And I cut through him like hot butter. He cried for an hour. And we were in the hot tub afterwards. I was just sitting there laughing at him. He was sobbing. He had the snot and everything coming. That was bad. Kyle Caulfield. You think he lives in Chicago and has kids and stuff. Yeah. So this then led to something else that you probably don't know what it is, but you've seen a bunch of times. How many of you have seen TCP/IP? I dare to ask, what is TCP/IP? What job does TCP/IP, what problem does TCP/IP solve? Huh?
It's an amazing.
Amazing question.
Isn't that also a protocol? That very-
Transport control protocol, definitely a protocol, yep. So it's TCP over IP. IP is internet protocol. TCP is transport control protocol. The problem this was solving is, you know what? We got a lot of stuff traveling over all these networks. Collisions happen. Data gets corrupted, stuff like that. So TCP/IP creates a scenario where you are guaranteed that your data will eventually arrive intact on the other end. Built into it, it'll resend corrupted or missing packets. So that's what it does. Now, but that comes with delay. How many of you have seen something called UDP? Okay, so I think it's Universal Datagram Packets. That's, when have you seen UDP? What were you doing with UDP?
Well, usually it's
100%. Yeah, video streaming. Why would you use UDP in video streaming instead of TCP/IP?
you don't need everything.
Right. Unless the thing is just horrifically corrupt where you're not getting anything. If you have one corrupt frame out of the 60 you were seeing per second, you're probably not going to notice. You'd rather that not spend time resending. You want to just look, don't fix it. Just do your best, man. just do your best, man. Oh my gosh, this is terrible. You guys don't know anything.
Should consult the internet with the whole Ethernet thing, because the thing is that I just asked ChatGPT to see what it said. It said no, it's not aware. I even went with that.
Our Wi-Fi here transports stuff over Ethernet. Your network interface cards in your computers are all Ethernet cards. That's what they speak. They don't speak other protocols. They don't speak other network protocols.
Yes, but it's still.
It's probably old data, or Wikipedia isn't that written by a public or something. If we're being, for instance, you've only ever heard people reference Ethernet as the wired network, right? So it's possible it's become synonymous with an underlying meaning. But I promise you the underlying meaning is Ethernet is a protocol it is a network protocol. It says nothing about the medium in which it's being transported. Could be wire. In fact, The earliest Ethernet cables were not what you see here. The early Ethernet cables were almost like the coaxial cables you see from like when cable TV comes into your house. And each one, so they had there was a T connector on your Ethernet connectors. In fact, the early Ethernet cards had both a T connector and the plug-in. This is predating Wi-Fi. So they had both of those. And so what you would do with the T connectors is you would create a string, like a string of computers. And so this is when you really see that lazy river thing. And then at the very end, when you ran out of computers to hook up, you ended it with like it was like a repeater. So whenever stuff got down there, then bounced back the other way. So the people could just keep dipping. So when I was a kid, there was times I had these networks strewn around my house with all sorts of different devices, just trying to hooked up into this stuff. I would modify Ethernet cards to like work with other devices. And now you're playing Call of Duty. People. Call of Duty's dead. What do we, is it Rainbow Six now? What's the Rainbow Six is the cool kid? So you guys know all about that. That's gonna play well in your first job, making a salary. No, what you'll actually be able to do is you'll be able to have camaraderie with the other jobless people. It's like that's what I'm here for. You meet up with them in the unemployment line. Next thing you know, you have your latest World of Warcraft raiding party. All right. So anyways, swinging back in, we have a lot of different technologies that are like PHP. What you saw in early PHP programs, as our computers were getting faster, as our internet was getting faster, we went from dial-up. How many of you have ever used dial-up? How many of you ever heard dial-up connecting? You hear the beeping? How many of you have heard that before? Or at least in a video or something? What is going on there? And nobody's saying it's got to be what is it, and NA17 or something like it. It's not that. All right, what's going on with all the beeping? This is called handshaking. And so you have two different computers talking to each other. Each of them has a modem. This is what predated the internet. Something called bulletin board services, BBSs. Early MUDs, which we talked about with our dungeon crawler. See, I'm swinging us back in. So we talked about our dungeon crawler ran on a BBS. So you'd have people join this multi-user dungeon, but the number of people that can join was only the number of people that BBS had a bank of modems for. So if they had 50 modems, you could have 50 people on at once max. Okay, but keep in mind, 50 modems equals 50 phone lines. Each modem has a phone number. You know, at some point they made it cooler where it had a phone number and then it transferred you to an internal system so they could then have one phone number that went to different stuff. This is the evolution of things. But all that beeping and crunching and all that stuff is called handshaking. And what the two modems are figuring out is how fast can we send stuff? I mean, the fastest you can send stuff anyways is the speed of the slower of the two modems. If you had one modem that was a 56K modem and another modem that was a 28.8 modem, the fastest you're sending is 28.8. 28.8 kilobits per second. 28,800 BPS, bits per second. All right, so when people say 56K, that was the early psych outs. Remember I've mentioned with like people taking advantage of you with your cable modems? It's like, well, it's 400 meg internet. Megabit. It's not 400 megabytes. Well, so anyways, they're negotiating the speed. They're figuring out what's the maximum speed we can talk at without screwing up. Why? Because they didn't have TCP/IP. They didn't have a way of fixing it. They had to get it right the first time. So they had to negotiate the fastest speed. They were confident that they wouldn't screw up until mom picked up another phone in the house. Then it didn't matter what speed you were going at. She picks up the phone, starts dialing grandma, and all of a sudden I'm kicked off the game.
That sounds like a personal.
Imagine a little 11-year-old Lippman. The rage, fury. And then you have to picture in the other side, the angry Jewish mother. Yeah. As I say, I mean, you've seen it before. How many of you saw the Return of the Jedi movies? Yeah, basically Jabba the Hutt. Yeah, you don't want to mess with that. My mom broke her tooth the other day in Africa eating pizza. So many of the pieces of that story don't make any sense, but it's all true. Doesn't help that my elderly father, who's a retired dentist, has decided that he still has it. And he can just find stuff around the cruise ship room that he can build this thing up and perform a crown. Yeah, that's the lineage this is coming from, people. All right. So anyways, that's what predated TCP/IP, and that's what we used to have to do. We used to have to figure out how fast can we talk before things messed up. Now we could just send stuff as fast as we can. And hey, if it messes up, we got a backup plan. That's not our problem. We don't have to do anything about it. Just resends it. You didn't get it? No problem. We're not going to even waste your time looking for it. You know, if you never get it, we might look and see what happened. That's those times when, you know, some construction site cuts through the one of the main trunk lines, you know, connecting the entire Midwest to the rest of the world. That happens when you have those like 3-day internet outages. They don't happen as often anymore, but. So anyways, in the very early days of the internet, you imagined that the websites were not overly complex. But as speeds got faster and people's reliance on the internet got more, and human beings were greedy, we always want more and more and more and more and more, the pressure was on the website developers to start coming up with more dynamic content. And more dynamic content means that we had to move outside of the browser. Remember, browsers only handle HTML, JavaScript, now CSS. CSS wasn't a thing back then. You had the predecessors to CSS back then, templates and things like that. So anyways, so as this happened, PHP was created as a development language for web. And people were then creating more and more complex programs because now they had something that was actually physically running on the back end web server, like Apache. If they're running Linux as their server, they're running Apache. There's actually some stuff that sits on top of Apache now, like Nginx, and how do you pronounce it? Nginx? Well, whatever. You have that, but it's a protocol. It's a application that sits on top of Apache. It'll install Apache if you don't already have it installed. But anyways, as people started having these back-end servers and they had modules like a PHP module that ran on there, now they can start writing their pages with PHP. But the problem is that we didn't have MVC back then. So you had a single web page. Instead of being called index.html, it was called index.php. And by the way, that when you see a file called index.html, that's the de facto home page for any site. So if you go to google.com and then you go to google.com/index.html, it'll take you to the same place. Your web browsers automatically are loading that. Now, actually, the web servers decide what page they'll serve if there's no page specifically requested. But index.html is one of those. So index.php says that extension on there says, okay, web browsers cannot handle this directly. It's got a PHP on there, not just an HTML. And then when we look at the stuff, there's stuff in here that is not HTML, CSS, or JavaScript. What is that stuff? It's PHP. So what they have to do is, as they're requesting that the index.php from the web server, The web server's job is to spit out HTML, JavaScript, and CSS. Well, it has PHP in here. So it has to run that program on the server, get the output of that program, which hopefully, if you're using PHP, the output of that program will be HTML, JavaScript, and CSS, and then spits that out. So now you have a dynamic sites. But what started happening is your index.php files started getting increasingly intimidating as you had more and more and more stuff in it. So to the point where it was hard to debug, it was hard to read, it was hard for everything. Keeping in mind that even in the early days, then now you're having multiple people working on the same files. You might have the programmer person working on some of the file because they're doing the programming stuff. You might have the designer person making the user interface stuff, also editing the same file. So you got this file of spaghetti code with all sorts of stuff in it, and everybody's editing the same file. It's just it's a bad situation. Introduce MVC. Well, before MVC, well, I guess this is introduce MVC. It's, hey, this is a problem. We need to fix it. What would be a good idea? Well, let's separate all these things that are in here so that if you're a data person, you can just work with the data side. If you're a design person, you work with the design side. If you're a programming person, you work with the programming stuff. And we're going to take those into 3 separate places so you can work with those things. Welcome MVC. We see MVC being a design pattern is an idea, not an implementation. So every time you work with a new product, Unity, Visual Studio, Android Studio, Xcode, you get to learn how did they implement MVC? What is their mechanism for connecting the user interface to the backend code? What's Unity's mechanism for connecting the user interface to the backend code?
The scripts.
Okay, so one way is you can attach scripts to the to game objects, and the Unity game engine looks at those scripts and spins up those programs. Okay, so that's one thing that happens. So they launch the programs, but how do your programs have an interaction with the game? It's a two-way street, right? One side is the game is requesting stuff or is sending stuff back to the software. Current location of stuff. Did a collision happen? We've been talking about these things, on collision enter, on trigger enter. So there's all these mechanisms for the actual game to scream back at the code and say, hey, stuff's going down. Okay. Is there a way for the code to send stuff to the game? Let's say that you wanted to have a variable speed in your game where the player can move at different speed 10, or you can change it to speed 20 or whatever. How do you accomplish that in Unity? You did it in your tutorial.
You set up a field.
Okay, what about the field? What do you do to that field to make it available to the Unity side of things? One word. Put one word in front of that field. No. Public. Just make your field public. The second you make a field public. Oh, here, do I have any scripts on anything here? There we go. We got a move script on this guy. All right. So I'm going to go to my project. Here's our. Where's my move script? Oh, it's called move example. All right, here's move example. All right, so ooh, do I want to keep the dark subscription benefits? What's all that crap? Oh, that's release notes. All right. What's all this crap? I'm in a terminal, where, what?
Right, it's the X. Right.
Huh,
Right. Oh, you're on it, right there. Good job.
thank you. I got the public answer right.
Okay, you may do it, you know, make.
Oh,
Show up on the edge, you have to export it. You export it in order to get it show.
okay. So you effectively define a field and then mark that field as an exported field?
Yep.
Okay, so it's more work.
If it's public, it's only available. Like,
Yeah, so it's more work, is what you're saying.
No.
Yeah, I get it,
More,
yeah.
It's
No, it's fine.
more specified, you know?
All right, so-
programming back.
So if we say something like int speed equals 5, and we, do I not already have a speed? Okay, that's fine. So I have an int speed equals 5, and then I go back into my Unity side of things. It's recompiling the scripts and stuff, yada, yada, yada. Where's my player? All right, here's my player. I see nothing new here, right? Same thing. If I go back into my code, I now just add public to this guy. Let it recompile. Whew. Now you see we have our speed available over here. All right, so I mean, you're not necessarily wrong there, but well, yeah, you're wrong.
No, I'm not.
If it was anything other than public, I would say that you would have a point. But public is something that's like a catch-all. Nobody actually makes stuff public for a real reason. What they really mean is, if they say public, they really mean just, hey, I want it to be accessible inside my namespace or inside the package. You know, they're not really using, they really mean package level or namespace level. But, so you're right. Instead of creating a whole new framework, we just leverage something that was already there. You know, we don't do that ever, like with RESTful APIs.
It's not a whole new framework. The language is made specifically for the engine. So the way it works is specifically for it.
But what about RESTful APIs? What do they use?
What?
Well, what's their backend? Do they invent something brand new for RESTful APIs, or modern APIs are all RESTful? Did they invent something brand new to make that work? What do they use? They use the HTTP protocol that came out prior to the internet. Hypertext Transport Protocol. The same thing your web pages use. You've seen the get, the post, the put, the delete. Well, your web browsers only use get. You throw PHP in there, well, you might do some posts if you don't want your username and password sent up in the URL. Then we encrypt it by putting a little lockbox on there, right? But then we say, you know what? Nobody uses put, nobody uses delete, and people aren't using get and post for their full potential. So why don't we write all of our APIs in terms of this protocol that's being underutilized in terms of its full features and has also been stress tested for, I don't know, we'll round down and say 50 years. That seems like it's gone through the paces. So let's use something that was already there that was being underutilized rather than invent something brand new that seems stupid. That's also attached to I mean, would you call Godot like a lesser program or a pathetic program? Like, which is like the more appropriate?
No, it's actually, I would say better than Python.
Better than Python?
Yeah.
Is it really a competitor with Python?
No.
Man, he's running into a dump truck. He doesn't have enough hours to sleep. I can't put up with this.
Python accepts strongly type. It's better.
All right, fine. What's this? Carnival. Oh, you were in the same meeting as him.
Yeah.
Except he let me know.
Oh.
Actually, I think he may have actually said he was in the meeting with you.
I don't.
You don't know if you don't know if you invoked his name?
I don't think I.
Nah, you're screwed. It's just nothing.
Or yes, I did.
And look, he's wearing the t-shirt that's 8 sizes too small just so his biceps pop. It's a what?
I showed the monkeys I had.
If I wore an XL, I wouldn't even have to do the Hulk thing. It would already be pre-ripped. Isn't that what the young people do today with their jeans?
Stop coming to go. Go with fun.
Don't all the jeans today have to have rips and stuff in them? That's like the thing, isn't it?
Yeah.
Like, man, let's pay 8 times the price for these things. And they came, they came pre-chewed by 3 fighting pit bulls. Then we left it outside in the rain to get it weathered for about a month. Then we toss a high-end label on it and charge it $200. That's what he said. It was just stupid. All right, shut up. All right. So anyways, we're talking here about MVC, and here's a mechanism. Here's part of the mechanism in which Unity exposes the coding side of things to the user interface side of things. Okay? Because MVC says, hey, it's a good idea to keep these 3 things separate, but to make that happen, you then have to have mechanisms for having those 3 things to be able to communicate with each other. Because you've separated them arbitrarily to make it easy to work on. But that doesn't mean those 3 things have nothing to do with each other. They still need to be able to talk somehow. So we know that we can add a programmatic aspect to a game object by attaching 1 or more scripts to it. But we also know that those scripts can expose variables to the Unity game engine, the interface builder, or whatever they call theirs. Interface builder was what Apple called their same thing with Xcode when iPhone stuff first came out. Yeah, so we had to have a way of saying, hey, I want to create variables, but I want those variables to be editable over in my game engine in case they want to change the speed or they want to do something like that, blah, blah, blah. All right, so this is the way we accomplish that. So whenever you work, and I'm not going to look at the model yet, we're going to attach a database at some point, but just understand that there will also be a mechanism for your C# program here to talk to a database on behalf of your user interface. And then we already have seen how our code talks to the user interface side of things, going both ways. Okay, so we're seeing MVC in action here. Did I actually write anything here? Hopefully not. I'm just going to delete most of this. What was that? Was there a threat? I heard a threat. I'm excited. With what? Leather or mother? Weather boy? What? Really? Oh, from the show Monk?
Boxing and UFC. Sorry, guys.
I'm uncomfortable learning about Weather Boy from someone wearing a child's medium t-shirt.
Take a large. I don't want to be fat and get a size up. I refuse to go past XL.
XL's the max.
XL's the max. We're not going
Because our modern day 2Xs are the previous day's largest.
But I taught him.
About in the gym.
Gym that way.
You know who made that famous? The governor of Minnesota. Former governor of Minnesota.
Simple.
Oh, Jesse the Body Ventura, former WWF wrestler. That was his, it was. That was in the early days of TV. Guys are killing me. It's just really bad. All right. So here I'm gonna gut most of these things. So what we want to do is we want to start looking at some interesting things that we can do with Unity, kind of connecting our code behind to our actual Unity thing in a way that you'll actually pay attention to instead of just blindly going through the tutorial until you hit the end and not trying to understand the stuff that was in between, all that stuff. So for starters, what I'm gonna do is we are going to get a side view here. Oh, actually, I want to get a. Let's start with this. And ninja. All right, we're gonna do this. I'm gonna drop this guy down a little bit. Then what I'm gonna do is I'm gonna duplicate him. So I just did a if you're Windows, Control C, Mac, Command C, then and then I did a Controller Command V to paste it. So I'm just gonna get another guy here off the screen some. All right, and if let me just make sure it shows us the thing that I want. Where's my play button? Move. All right. Boom. Oh man, shouldn't have used the sphere.
It's very, oh my God.
There's some beautiful puns. Oh my gosh.
Oh my gosh.
But using gravity, why wouldn't why wouldn't the second ball fall off?
Because it was perfectly lined up. I'm gonna unperfectly line it up. Imperfectly line it up. Hopefully it doesn't miss now. It just lands behind him, besides him. Boom. All right. Ooh. All right. Yeah. Well, we'll be here in a second. All right. So now that is how we might, well, that's just kind of messing around with the editor, seeing gravity work and stuff like that. Now, how do I make this top guy not fall? I could turn off rigid body because rigid body comes with gravity, right? But you're right. In the example that I'm going to show here, this guy doesn't need mass. He doesn't need mass. But what I'm going to do here, just to keep things separate, I'm going to create a. Actually, I'll go ahead and create a empty game object, and we'll call this guy the source. All right, and we'll move the empty game object basically up where that other guy was. Okay, I'm just moving him up so we can't see him. All right, and then I'll go ahead and get rid of that second guy. Oh, where's my delete? All right. Now remember, our source, which is a game object, which has a transform. We just can't see him. He doesn't have gravity. He doesn't have any other special things, but he is a game object. He has a location on the screen. And this is important because a lot of the things we do in Unity is using game objects as location beacons for a starting point for other things. So for example, since I have this guy, if I make him available to my code, I can then get have access to him programmatically. Now, how do I make him available to my program? So I've just put something on my view. We're talking about MVC. I put something on my view, and I need to access that something from my code. What do I do? Go ahead.
I think you would first need to create a script.
Okay, I already have a script, but you're right. We need a script to accomplish this. Okay, go ahead.
Right. Script. And that once you do that, drag and drop the script or select it.
Okay, so here we're gonna follow your instructions. So we're gonna create a where's my scripts? You guys have to help me with the eyes here. I don't have them.
That's the third one.
Ah, thank you. Thank you. We'll just call this guy test. We'll grab our game object here, source, make sure he's selected, and I'll just drag test over there. So now it's added. Okay, so we have our script. I'll go ahead and open that script up. We can bounce back and forth. So what do you want me to do next? I want to, just so it's clear what I'm asking for. See, back row, this is why you guys don't know anything.
I'm in the second.
Front row, you guys don't even have an excuse. You're right here where This is like what this is why I sit in the front row at chapel, because God sweeps through there first. I'm not sure if that's biblical, but it feels that way. It feels that way. I mean, because at that point he's getting a running start, so he's kind of wiggling back and forth until he kind of gets into a he's got a cone of movement initially, and then he gets his trajectory. All right, so we're in here. I want to be able to, in this code here, I want to be able to control that game object that we created out there. That is an empty game object, but he's still a game object. How do I pull this off?
Do you wanna control like the body?
I want to do whatever I want to him. I want to have full programmatic control over a game object that currently only lives in my view. So this is model view controller. We're seeing how this guy implements it. And you did this on your tutorial as well.
You can make it public.
Make what public?
You can make your field public.
Okay. Tell me more. What should I type here?
And ever field.
What am I trying to manipulate that's in my view? What kind of animal? Cat, dog, or game object? Game object. So we're going to have a public game object. What do you want to consider him? We called him, what do we call him? The source out there. So you want to name him the same thing in here? So we'll call him the source. All right. So now I have a public variable here named the source. Now, what if I want to make changes to this guy? I want to change his transform or something like that. How do I make this guy first actually connect to the guy that's out there? Because right now I have this view, right, that has a game object called the source, and I have this script that has a public field that I happen to name the source. I could have named it whatever I want. How do I make those two talk? Go ahead.
Firstly, export the script.
No,
Drag and drop the other objects into the script in the editor.
You'd export the whole script? Why isn't the script
Oh, no,
already?
sorry, not it's
Man, he tries to like,
export
he
the
can't even get his digs right.
You can drag and drop it onto the keyboard, right?
All right, so I'm gonna grab the source here. I'm gonna grab the source here now. Now, is this needed? So what he's saying here is he wants to say, okay, we're just gonna grab the source. We're gonna drag it over there. So now I've associated a game object with this script called the source.
Yeah, I think do that though.
Why not?
Because on the actual source, things have it as this.
Oh, I don't actually have to let the script know about the source because the script is already attached to the source. So then how do I talk to the source? How do I make changes to the source then if I don't need that? If I don't need this public thing, which is still important, right? This still lets us decide how things work. And I'm just gonna move forward a little bit for us, and I'm gonna say public int the count, and I'll start it off at 20 for no good reason. All right, but you mentioned that, hey, because the script is attached to the thing called the source, I actually do not need to create a public field for it because I already have access to it. But how do I have access to it? How do I access that game objects? How do I, from within this script, test.cs, how do I access this particular game object, the source? How do I access his transform? Because I want to, he only has a transform, first of all. So if I try to access any other aspect of him, I'm going to come up short. Go ahead.
Not this dot.
Well, I don't know. Is that an answer or a question? This is a question. This, you have a theory?
My theory was that have an add component under the specifically, so that something. That's like,
He's closer. All right. So this, what is this? If we are inside of this class and I say this, first remind me, what is the this keyword used for? How does an object talk about itself from within itself? And what am I? Whoa, what did I do? What am I? Well, no, hold on. This inside of this class is an instance of mono behavior. So if I say this, I'm talking about this particular instance of mono behavior, right? But what do I want? Do I want the mono behavior? Or do I want the game object that this mono behavior is attached to? Okay, now, if you just say this dot transform, it will work because this program tries to be for non-programmers just like Python. It lets you accomplish crap that does not actually make computer programming language design sense just to make things easier for the people who are just going to randomly do crap. And then all of a sudden, they learn that that's the way it works, even though that's a complete hack. It's syntactic sugar. So we're not going to do that. We're going to say, hey, I want this mono behavior's game object. That is the game object that this mono behavior is attached to. I want that dude's transform. Okay, and I want that dude's transform's position to be equal to something else, whatever I want to do. All right. So I can make some manipulations on that guy. All right. Who? Well, okay. I think what you're talking about is if you want to make the position, I mean, that would be the finishing of this. So you would say the position I want to be a new vector 3 at, this is the XYZ coordinate. So maybe we say if we want to keep it at the current X and we want to keep it at the current Y, we want to just change the Z, we would say this dot game object dot transform dot position dot X, comma, this dot transform or this dot game object dot transform dot position dot Y, comma, whatever you want Z to be, 7. And then it'll just make it go, actually 7 will make it come closer to us. All right. But if that's what you really wanted to do, you wanted to just shove it in a little direction, you can do that. Or look at what else could you do? Instead of spelling out all the X, Y, and Z's.
You do a plus equal.
Plus equals what?
Well, then you do 0, 0, however much.
Ah, plus equals another vector 3. Matrix math. Super scary. But this guy does all the work for you. So he's saying, well, if you want to change the position, then just take the current, well, actually, what he actually wants to do is just that, so he doesn't have to write the position thing again. And he wants to do a new vector 3 of 0 dot 0 dot, what did I say, 7? Like that. So we're going to create a brand new vector 3, 0, 0, 7. And we're going to add that to the previous vector 3 associated with position, giving us a brand new vector 3 that has everything the way it used to be, but with 7 added to whatever Z used to be. That's not scary at all, is it? I mean, as soon as you got past the whole vector 3s are scary part.
You can do it even easier.
How do you want to do it easier?
Position dot Z.
Plus equals?
Yeah.
That might be true. I haven't done it in a while. Yeah, if I recall, position and transforms are like read only from changing them in line. I think you have to make any way you cut it, you're going to have a new vector 3 involved. Yeah, I think they're read only. I think you have to rewrite the entire vector 3. I don't think you can get down to individual components.
Variable game.
Well, you can write a function that does it.
Yeah.
So it's not a. No, I would say that's correct because you don't want to let somebody. You don't want to let somebody arbitrarily change your like Z without taking into consideration your entire position. Yeah. Is that any worse than this? Yeah.
nitpicky, I can't.
No. I'm with you. Let me think about that. Let me think how I can give you a better answer to that. But in any case, shut up. You got 3 more minutes with me.
Sir, yes, sir.
All right. So, okay. So I would say that what we see here is the appropriate way of doing this. And this is something that as computer science majors, you want to start getting over your fear of math, minus Carnival, who loves math, right? Yeah. So you want to get past your fear of math because just like computer science, math is filled with a whole bunch of scary sounding stuff. Integrals, derivatives, vectors, blah, blah. They're all easy crap. They're not hard stuff. You're just so terrified you don't want to jump into the swimming pool. So you're over there in the kiddie pool just splashing up water. I like the number 6. It's recorded. That's going to become a meme. You guys have not, they don't even let me compete in the belly flop contest in the cruise lines anymore. Yeah, it's like me versus like a 12-year-old. I mean, come on, they to compete at this level. They're all right. So shut up. All right. So in any case, we can make manipulations this way, but what we want to do is we want to experiment for our homework with 2 things. We want to experiment with the instantiate function, where we create a game object and we create new instances of that game object at a particular location. So I'll let you look at the documentation for how you might do that. And we want those things to fall out of the sky, landing the thing below us. But each time a new one is instantiated, we want to randomly move it a little bit to the left, a little bit to the right, or a little bit forward, or a little bit back, so it doesn't land dead center, right? And we want that guy to, and then we want to, based on that variable, increase the number of things that are instantiated per heartbeat. So all of a sudden you'll have a rain of randomness coming down in your game, smashing into that guy, okay? And I want you to keep pushing it until you start feeling your game slow down. And what we're going to do is we're going to talk about on Tuesday how we can avoid the game slowdown thing. All right, so I'm purposely running you into a wall using documentation for 2 things. Random number generation, which hint, hint, is almost identical to Java's. And then the instantiate thing, which is just going to be, hey, I want to create an instance of this game object that has a rigid body with gravity. I want to create an instance of it at this game object up here, this empty game object, and then just nudge it. Let them fall out of the sky. Do that in bulk. Capiche? All right, I'll put the assignment up. I will see everybody on Tuesday. Chapel, front row, 9:30. God sweeps through there first, allegedly.